So we're going to leave table behinds and start looking at a couple more graphs. We have here a frequency polygon. Now frequency polygons are line graphs that use the class midpoints on the horizontal axis and either the frequency or number on the vertical axis, or if you're doing a relative frequency polygon, it would use the relative frequencies. So this particular graph, because it has number of over here, that's a frequency, which means this is a frequency polygon right here. Now it wants to know what n is. N is the sum of the frequencies, right? So we want to add 896 and 490 and so on. Now we can do that with Desmos as we've done in the past. Let me show you real quick. There we go. We add them up in Desmos and there they are. But now that you know how to use a spreadsheet program, you could use a spreadsheet program. You could just add a sheet, right? If I click the little plus sign, I have a sheet and I can just add them. I can say 896 and 490 and so on. Put them in their own little column. And then down below that, if I type equals, it already knows what I want to do. Indeed, I want to sum them. And there we have the total right there. So now that we know how to do this, we can use it for other problems as well. So we find it's 2, 5, 6, 7. Right, there we go. That's the sum. So either with Desmos or with a spreadsheet program, we had 2, 5, 6, 7. Now 2, 5, 6, 7 what? This was the ages of Medicaid beneficiaries, and this is how many beneficiaries there are. So these are Medicaid beneficiaries. So 2, 5, 6, 7 Medicaid beneficiaries. There we have it. It's a sample, right? Okay, now find these values. The third class is midpoint. Okay, now remember, they are fake classes, right? I think I forgot to say it, but there are fake classes at the beginning and the end. So this looks like a class, but it's not really. It's a frequency of 0. That's just the way polygons are built. So the first class is actually right here. This is the first class's midpoint of 5. The second class's midpoint's right here at 15 for its midpoint. And the third class's midpoint is right here. It's 25. So 25 is the third class's midpoint. So what's the fourth class's limit values? So the third class, the middle is right here. So the class itself, if you look, class 1 is right there. Class 2 is right there, and 15 is the middle of it. Class 3 is right here, and 25 is the middle of that. Class 4 starts right here. So what's the number that's halfway between 25 and 35? Well, that's 30. So 30 all the way up, 35 is the middle of the class. 40 is the start of the next class, so 39.9, because this is age, right? So 39.9. These are years, right? Because you don't have to write the years, but just to remind yourself, these are years. So the first class starts at 0, the next class starts at 10, the next class starts at 20, and so on. You can tell because those numbers are halfway between the midpoints. What's a class width? Well, the class width is the same distance from midpoint to midpoint to midpoint. 5 to 15 to 25 to 35 are all 10 apart, just like 0, 10, and 20 are all 10 apart. So you could take 25, take away 15, and you would get 10, right? Or if you like, you could take 15, take away 5, and you would get 10. Or if you want to use the limits, you could take 20, take away 10, and that would get you 10. The modal class, the most common Medicaid beneficiary, is right here at the 5. So it's 0 to 9.9, because remember 10 is the start of the next class. So 0 to 9.9 years old. That is the most common age of a Medicaid beneficiary, and it's true. Children are most likely to be Medicaid beneficiaries. All right, how many of the Medicaid beneficiaries were less than 20 years old? Well, less than 20, let's see here. 20 is the start of this class. So the 311 is with the 25, so that's more than 20. That's the 20 and higher. Less than 20 would be these two groups, because this is the 0 to 9.9-year-olds, and this is the 10 to 19.9-year-olds. So less than 20 would be those two numbers. So 896 plus 490 would get us. Now, again, if you have a spreadsheet program and you've typed them in, you can actually just highlight them, and in the bottom corner it tells you what they are, 1386. Or you could use your calculator and take 896 plus 490, and you'll still get 1386. So whichever way you want to do it, we get 1386. All right, that's a frequency question, right? Because it's asking how many. How many means we're going to add frequencies, which we did. Now, that's going to be different than the next question, which is a percent question. So we know we're talking about 50 years or older. All right, so let's look. 50 is right here. So this is 40. This will be 50 right here. So 50 and older would be these two groups, right? 50 to 59-year-olds, 60 to 69-year-olds, and 70 would start right there, but we've cut them off at 70. So more than 50 would be these two groups. So that's 193 plus 187. So we want to take the total in the categories and divide it by the overall total. Okay, so the total in those categories is 193 plus 187. And we divide it by the big total, which we already found. It's 2567, right? That's little n down here. Okay, so we need 193 plus 187, right? 380. Or again, if you're in a spreadsheet, you could just add them up. There we go, 380, right, bottom right corner. So we know this is 380 divided by 2567. All right, so now we'll go back to Desmos and say, hey, what's 380 divided by 2567? And it tells us it's 0.148. And since they want it to be a percent, we're going to switch this to 14.8%. That way we have one decimal place on our percentage. Now, what about this shape? Well, you can kind of see the shape, even though it's not a histogram. You can tell that it has a high piece here and then it tails off to the right. So high piece here tails off to the right. That's skewed right, very much skewed right. Right? It has the tail to the right.